According to NEC 220.61, a neutral conductor is not required for a delta system. The code explicitly states that for three-phase, three-wire delta systems, no neutral conductor shall be required. However, while a neutral conductor isn't mandatory for a delta system, several conditions might make its presence beneficial. Firstly, consider ground fault detection. A neutral conductor provides a dedicated path for ground fault currents to flow. This facilitates faster and more accurate ground fault detection, which enhances safety and reduces potential damage to equipment. Secondly, certain sensitive electronic equipment may require a neutral conductor for proper grounding and voltage stabilization. The neutral helps to maintain a stable reference point, preventing voltage fluctuations that could harm sensitive electronics. Thirdly, contemplate future expansion. If there's a chance of adding loads in the future that do require a neutral conductor, installing one during the initial installation phase might be a prudent decision. This eliminates the need for costly and disruptive retrofitting later on. Fourthly, a neutral conductor can provide convenience for maintenance and troubleshooting. It allows for the measurement of voltage to ground, which can be helpful in diagnosing electrical problems. In this specific scenario where the feeder from the 2000 amp switchboard is 3-wire plus 1 ground, it's probable that the 400 amp switchboard has already been installed with a neutral conductor. Whether or not this neutral conductor is actually utilized depends on the characteristics and requirements of the specific loads connected to the 400 amp switchboard. If the loads are purely three-phase and don't require a neutral connection for their operation, the neutral may simply be present but not actively used. However, if any of the loads require a neutral for voltage stabilization, ground fault protection, or other reasons, then the neutral conductor would be essential for their proper functioning.